Hello, welcome to the TIFR GS Math solution 2024. So let's start with question 3 in the video number 2. So V and W are non-zero finite dimensional vector space C. Let M be the dimensional vectors and C linear transformation of this thing. Okay, and let N be the dimension of the space R in a linear transformation viewed as a real vector space. Then what is the relationship between N and M? So pretty easy. So in this case the equation deals with the dimensions of the vector space. Okay, so let V and W be the non-zero finite dimensional vectors in the space over C. Okay, so C linear so a C linear transformation V is W can be viewed as a R linear transformation by restricting the domain and codomain. Okay, now in this case every C linear transformation is following here. So the dimension of the complex vector space which we have over here when viewed as a real vector space. So complex vector space is viewed as a real vector space. Okay, so it's twice its dimension as a complex vector space. So this is because of every complex vector space is actually can be expressed as a linear combination of the basis of the vector and the multiplication with its imaginary unit. So therefore the dimension of the n space vector which is given here of R linear transformation of V is W viewed as a real vector space, and this is twice the dimension of the M here. So n equal to 2m. So C is the correct answer. Let's proceed to question number 4. So in 4 what they have given, so in 4 it is a real vector space is there, infinite sequence of real numbers are also there. Let W be a space consisting of this sequence which satisfy the relationship. So what is the dimension of W? So what is the dimension of W here? So to solve this problem we need to understand the given relationship that defines the subspace W. Okay, so the relationship is what? A k plus 2 is equal to 2 a k plus 1 plus a k. This thing is there, k equal to 0, 1, 2. This implies that one of the first two terms are a0 and a1 of a subspace in W are given. So all the subsequent terms are determined by this recurrence relation. Let us consider the possible values of a0 and a1. Case 1, a0 equal to 0, a1 is also equal to 0. In this case the subsequent all values will be 0, 0, 0, 0 in W. Okay, then a0 equal to 0, a1 not equal to 0. In this case the sequence is uniquely determined by the value of a1. Okay, so for example a1 equal to 1 we can take, so the sequence will be 0, 1, 2, 4, 8. So in that way we proceed. Next is a0 equal to 0 and a1 equal to 0. In this case the sequence is uniquely determined and this one will be 1, 0, 0, 0 in that way. Another case is a0 not equal to 0 and a1 is also not equal to 0. In this case the sequence is uniquely determined the values of a0 and a1. So therefore W consists of all sequences and that can be generated by choosing this any two real numbers a0 and a1. So option number 2 is correct. So any two values. Okay, the next video will solve from question number 5.